All right, folks. I'm obviously not going to go through the entire year's PowerPoints one by one as we did when we first did them. I'm going to try to focus on the things that tend to get concentrated on that I have seen in the release exams. You've seen them too. I've given them all to you. So hopefully you can tell it from there as well. So we started off Unit 1, which is the physical Earth, which is made up of the hydrosphere, atmosphere, and lithosphere. These are all the non-living components of the Earth. The hydrosphere is all the water of the Earth, of course. It's important to know the special properties that water has. Wide liquid temperature range. It's very high capacity for transferring heat. The fact that it's an ideal cellular fluid, and also the fact that it expands when it freezes, very unique property of water. Also, its distribution around, how much roughly is in the oceans, ice, groundwater, surface water, and atmosphere. Those are your different sinks for it. And also the way it moves between those. That's what we call the water cycle, of course. You need to know a little bit more than just your basic evaporation, condensation, precipitation. You need to know about the components of transpiration, sublimation, advection. Those will be something to look at if you're not familiar with those processes. Just know what they are in there. And then one of the big things about water that has made life on Earth habitable is the fact that it does transfer energy so well, and of course it is a fluid, so it's able to not only absorb a lot of energy, it can move it around the Earth, and it does that mainly through ocean currents. So there's a lot of focus on the AP exam on ocean currents. You've got the wind-driven ones that are on the surface, and then your density currents that occur when the water gets colder or saltier, it sinks. And one of the most well-documented ones of those is the El Nino. Actually, the El Nino is the Southern Pacific current, but the El Nino itself is a circumstance that happens where this system is slowed down. And this is, you get a lot of questions on this, as you saw in your review test. You had like 2 or 3 of them on this particular phenomenon alone. One of the reasons why is because for some reason we do have what's called the El Nino, which stops or reverses to some extent this normal pattern of flow of that. That causes a lot of climatic changes and biological changes. So make sure you're familiar with not only, of course, the normal conditions and where this current pattern occurs, what happens, and what it affects, at least in this particular area, when you're in an El Nino situation. And like I said, it's a popular thing to ask about. So I would know the details of the El Nino. And by the way, La Nina is the opposite, so if they do have to ask about La Nina, I haven't seen it yet, but just think of whatever the El Nino is and put the opposite conditions.
They're probably going to put something like that on there now, just because you said it.
You're right.
That's what happened with AP Psych. He said, this has never been on the test, but it might, and it was.
Just because they know you're taking it, this is all I'm sure that's what we'll
all right, La Nina.
Your aquifer is a good thing to know, shallow versus deep aquifer, where they're from and everything. Maybe you should move.
No, I got
okay,
it.
You're good.
There.
All right. So this will be a good diagram to say that. We're fortunate here in Florida. We have a very good example of that, knowing that the aquifer and surface water, the shallow aquifer, they're all continuous, and the effects of sinkholes and the difference between deep aquifer water and shallow aquifer and that kind of stuff there. Pretty well detailed in this particular diagram. And then we have the atmosphere. And this, of course, is the gases that surround the Earth. You would want to know the composition of 78% nitrogen and 21% oxygen and so on, the mixture of water vapor and argon and carbon dioxide, etc. Otherwise, the layers also, these are layers that occur or were established because of the way the temperature changes as you go up in the atmosphere. But you do need to know them by name and by order: troposphere, stratosphere, mesosphere, thermosphere, going from ground up. Most of the stuff that happens, weather, greenhouse effect, most of the gases in the atmosphere are in the troposphere where we are. The effects of pollution also as well. The stratosphere's claim to fame is the fact that the ozone layer exists there. But otherwise, mesosphere, thermosphere, really not a whole lot going on there. It's almost in outer space, so we don't really see too much about those. Now, I did go into weather with you. Besides the seasonal changes, the subject weather, I haven't really seen much on it, like with air masses and things like that. But you do need to know the wind patterns of the Earth, what causes the wind patterns of the Earth here. And it is the heating of the air at the equator causes it to rise, and then it moves toward the poles and sinks down at the 30 degree parallel and so on. One of the important things to understand about that is that where that air is rising, you have low pressure. Low pressure means more evaporation, which means more precipitation. That's why along the equator we have our rainforests because of that phenomenon. The opposite of that happens at the 30 degree parallel, what's coming down, so that's a high pressure area, which means less precipitation. This is where we find a lot of our deserts along there. 60 degree parallel, more evaporation. It's colder, so not as much evaporation, but that's where we have a lot of our snow that takes place. And then your poles are actually some of the driest places on the planet because of that high pressure as well. So those are your north and south winds, and the different pressure zones are based upon that. Also, the spinning of the earth and the Coriolis effect are what give it to your slanted trade winds and easterlies and westerlies and things like that. Like I said, I haven't seen much on air masses in there. They're just big, large sections of air that have certain temperature and humidity properties, and when they move around and interact with each other, that's where your storms typically produce. But like I said, I haven't really seen a question specifically on this. This definitely you need to know. You definitely need to know your seasons, why we have seasonal changes, tilt of the Earth's axis, know the details like the months that the solstice and equinoxes occur, where the sun's focus is on each one of those days, how it moves between those particular ones. They went so far as, that one to ask where you would have 24 hours of daylight. That's going to be in the Arctic Circle in the summer solstice and the Antarctic Circle during the winter solstice. So be aware of that particular phenomenon and the reason why we do have those seasonal changes. Tilt of the Earth's axis.
Looks like devil horns.
A little bit. Questions anybody about hydrosphere, atmosphere so far? All right, lithosphere, the Earth does have an active crust that is unique amongst the planets. What you would need to know about this is the different types of interactions as plates either come together or move apart. In particular, converging. There's a number of different things that happen on converging, whether or not they're continental plates or oceanic plates converging with each other. So know your different interactions there. The examples, we've got some examples here. Where they occur is a good thing to know on Earth. One of the things that I stress to you is that if you consider the fact that the Pacific Ocean or that the Americas are converging or moving towards Asia and Australia, that you have a whole bunch of convergence all through the Pacific Ocean along the rim of it as well as in the middle of it, and that causes a lot of the different types of geological formations and earthquakes and tsunamis and deep sea trenches and things like that you find there. On the other side, of course, you're going to have the opposite happening in the Atlantic. It's actually getting bigger as these continents spread apart there, and therefore you have a divergent fault line, mid-Atlantic ridge all the way down, and the crust of the Earth is spreading open there and producing new crust and basically pushing the continents in the opposite direction from there. Okay, questions about different types of plate interactions and stuff? So familiarize yourself with those and their locations roughly. Now the rock cycle is important because this is how nutrients are distributed as rocks are eroded. The minerals in the rocks settle down in, they become part of the soil, and that's where a lot of plants get their nutrients from. So that's an important thing to know. However, I haven't really seen any questions specifically about like metamorphic versus igneous and sedimentary and all that kind of stuff. But it's there in case they do. Like you said, they'll maybe ask about it now. But really haven't seen the rock cycle specifically mentioned on the environmental science test. Don't worry about that. That's later in mining there. Okay. Any questions about Unit 1? We already finished it. How about that? Unit 2, ecosystem structure, or Unit 2 is the living world, or the biosphere, or whatever you want to call it. We start off with the ecosystem. That's your basic unit of observation. The entire ecosystem is all the world connected together. That's what we call the biosphere. So that's our fourth sphere. So an ecosystem is made up of the non-living parts of that ecosystem. Water, wind, temperature, all those other kind of things, as well as the living parts of the ecosystem, which we call the community. That community is made up of populations, which are all the members of the same species. And each one of those populations, of course, is made up of individual organisms. So that's your basic levels of organization of the ecosystem. Energy and biomass travels through the ecosystem through the food chain. So of course you want to know the basics of that, which you guys should all know. But you should know primary or you should know representatives of each one of these producers: primary, secondary, tertiary consumers. Also decomposers, what the role of decomposers are. Let me advise you on this. The thing that most determines your position in the food chain is what you eat, not what eats you. So for example, people are not actually at the top of the food chain because we primarily are primary consumers or secondary consumers. They're omnivorous, of course. But most people around the world are actually eat a primarily vegetarian diet. So we tend to actually consume more here and here. We don't tend to go around eating a lot of snakes and cats and stuff, right?
I hope not.
Another important concept there to understand is what we call the ecological pyramid. And that's based upon the fact that in the food chain, only about 10% of the energy and biomass, and that's what food is, energy and biomass, is passed on to the next level. And so consequently, you're only going to have about 10% as many primary consumers by mass as you do producers, and 10% as many secondary consumers or carnivores as you do primary, and so on up to the top of the food chain. The amount of food that does get passed on to the second level, by the way, is the net primary productivity. So make sure you remember the primary versus net primary productivity, the gross versus net. The gross is total photosynthesis going on, that's food that's being made, but then the plants use a good portion of that, and then the net is what they actually transfer to the next food level, the next trophic level, excuse me, which is really food level, same thing. All right, since that is the way an ecosystem is structured, as you go up the food chain, there's less and less organisms, less and less biomass. What that means is that if you have a toxic substance like persistent pesticides like DDT, or toxic metals like mercury, something that doesn't break down and decompose, that when it goes to the food chain, it's not going to go at a 10% level because organisms don't digest these substances. Number one, they can't. And number two, particularly invertebrates, they have mechanisms that tend to store it away within their tissues so it doesn't go through and damage their system. Okay, that's called bioaccumulation, by the way, when an organism, over its lifespan, when it encounters toxins, stores it away in its body so it doesn't harm the rest of it. So that over time, a larger, older sunfish, for example, is going to have more, let's say this is DDT in it, it's got more DDT in it than when it was younger. Okay. That's bioaccumulation. Now, biomagnification is what's actually illustrated here, and because of the fact that these organisms are not getting rid of those toxins, roughly the same amount of toxins going to each level in the food chain, but the amount of actual organisms that are at each level is much less, 10% by 90% less, so it's only 10% of what there was before it. So, consequently, that toxin becomes more and more concentrated. Okay, it's like a fraction. So in this case, the denominator, I had to think about that for a second, is getting smaller while the numerator is staying about the same. Therefore, the overall number is actually getting greater. The concentration is getting greater. Questions about biomagnification, bioaccumulation, ecological pyramid, food chain, all that kind of stuff? No?
You should teach math.
Yeah, I don't think so. All right, natural selection, of course, survival of the fittest, and with the reason why those organisms survive being passed on to the next generation, therefore makes the whole population more fit to survive in a particular environment. Natural selection will occur with organisms in an environment until they're well adapted, and it pretty much goes into neutral as long as the environment stays the same. But if you then go from there and have some type of environmental change, then natural selection will start to kick into gear, so to speak, when that environmental change selects for certain organisms. I'll give you an example, and I'll use the example that is most commonly referred to on the exams, and that's examples of pesticide resistance. Same thing would work, by the way, for antibiotic resistance. With pesticide resistance, you have, let's say you've got potato beetles, and they're in their normal state, well adapted to an environment that does not have pesticides in it, and all of a sudden a farmer comes along and sprays them, that's your change in environment. And for the sake of this example, let's say 10% of those beetles had something genetic that made them resistant to that pesticide. So now what has happened is that pesticide has selected out the organisms that were resistant to that pesticide. It selected them by killing all the rest of them. Okay, so that's what we call what's called natural selection. And in this case, of course, it's pesticides. It's not really natural, but you get the analogy, hopefully. So what that means is that those that are left over, the remnant of the organisms that are pesticide resistant, they're going to reproduce and therefore pass on those pesticide resistant genes to their offspring, and therefore the population as a whole will be pesticide resistant. So whereas before the population was only about, what did I say, 10%? 10% pesticide resistant. Now, depending upon the genetics of it, it's going to be, 70, 80% pesticide resistant or more, because that gene was passed on to the next generation. Okay, so everybody clear on how pesticide resistance is an example of natural selection? Very common for them to ask you natural selection questions based upon pesticide resistance. And like I said, antibiotic resistance, same thing. It's just using antibiotics and creating antibiotic resistant strains of bacteria like MRSA. And if you're not sure about the pepper moth, I don't go into it right now, but look it up. That's a classic study that showed natural selection. All right. So what natural selection then does, as I said, it adapts the population to an environment. What it really does is it kind of, within an ecosystem which has certain physical quantities of food and shelter and water and air, if it's aquatic ecosystem, oxygen, if it's aquatic ecosystems, all the different things that things need, it only has a certain amount of each one of those, and therefore through natural selection, basically that process partitions off the resources of that ecosystem to its different members of its communities. All right, so let me give you an example to explain what that means there. For example, and those different areas that organism occupies for the things it needs, whether it's food or the type of habitat, the shelter it has, also things that depend upon that, that's what we call its niche. So it's going to fit into a certain specific area in that ecosystem, and it tends to work in a way that everything ends up having a particular role in the ecosystem and things work out real well. So one example of this is koala bears. Okay, the thing that makes them a specialist type species is that they're one of the few things that will actually eat eucalyptus, and that's almost all that they eat are eucalyptus tree leaves. So how did that end up being that way? Well, let's just say, for example, that thousands of years ago you had eucalyptus trees and fig trees in the forest. And even though figs are delicious and maybe eucalyptus trees leaves are not so much, I would imagine, there was kangaroos around. And kangaroos are bad. If you've ever seen them box, they're not something to mess with. And let's say that they both wanted those figs, but the koalas were no match for the kangaroos. And they said, well, you know what? Our fundamental niche, which defines all the things, all the places we can live, all the things we can eat, etc., is eucalyptus trees and figs and whatever else there that's edible. But we're going to only eat the eucalyptus leaves because nobody else is eating them. And we don't have to fight kangaroos to get to it. And life will be much happier, but we have to adapt to, or natural selection into, that role of just eating eucalyptus leaves. And so that becomes what we call their realized niche. Okay? So they could eat all this, but because there's too much competition out there, and by the way, that's the big thing in ecosystems. It's not whether or not you get preyed upon or whether or not you're going to be susceptible to disease. It's the competition for resources, food, water, shelter, and those kind of things. That's why you see so many animals are very territorial. For example, the raccoon. Now, he's a generalist. So he's going to eat the fig trees, the figs, he's going to eat the eucalyptus leaves, he can eat whatever he can and wherever he wants to, because I don't know if you know much about raccoons, but they are nothing to mess with. Okay, they're very aggressive. Carrying rabies is not a particular factor that's not like an adaptation, but they do sometimes, so you should be careful of them. But they will come up and flat out chase you off from their garbage can and stuff. So that's an adaptation that allows them to eat whatever they want, because rather than finding something that nothing else wants to eat, they eat whatever they want and they chase off whoever tries to compete with them, unless of course it's the bear or something.
Or some homeless person.
Yeah, well, I'll tell you what, between a homeless person and a raccoon, I put my money on the raccoon. I would not mess with them myself, frankly. So, any questions about niches and how natural selection tends to put things into a particular niche? All right, some niches, they have specific, some niches are more equal than others. They sometimes say, for example, what we call keystone species. These are organisms that have a lot of interrelationships with other organisms and therefore affect their populations quite a bit. Oftentimes they're top-level predators. And the only definition is that if you remove them or reduce them in number, they have drastic effects overall to that ecosystem. And they call them keystone, like the architectural element, that if you knock a keystone out of an archway, that archway will collapse. So it's the key important piece to have in there to support the weight of the structures above it. Foundation species tend to form the overall structure of an ecosystem itself and provide habitat. On land, that's usually trees or, it could be grasses and stuff. Usually the producer. In the ocean, coral reefs take that particular role as well. Of course, kelp forests and all those kind of things. Even though your producers, of course, their main role is to make food, a lot of times those producers also provide habitat. And it's foundation organisms that provide or alter or produce a particular habitat. So sometimes things like beavers, which will basically make ponds when they dam up a river and things like that behind it, they are also oftentimes considered foundation species. Although they're also considered a keystone species as well, so I want to keep that in mind. All right. So ecosystems are these different things that healthy ecosystems do for people, providing food, recreation, fresh air, water filtration, a whole bunch of them as you can see there, so you might want to review those. All right, nutrient cycles. Okay, so carbon cycle, main processes in this, photosynthesis, respiration, that's where the vast majority of carbon makes its way back and forth between parts of the biosphere. But there is a factor of carbon dioxide dissolving in the water and producing, calcium carbonate shells and that kind of thing. Also, we have a big role in the carbon cycle because we dig up and burn fossil fuels, releasing CO2 in the atmosphere, and also we cut down trees. That also releases CO2 into the atmosphere as well. With the nitrogen cycle, the main thing about the nitrogen cycle that's unique is that most of the nitrogen is in the atmosphere in an unusable form by plants. Plants cannot take into the atmospheric nitrogen form and use it. So, but bacteria can do that. There's certain bacteria, we call them nitrogen fixing bacteria. They basically fix the nitrogen so the plants can use it. And therefore, that's how that gets in. The nitrogen gets in the system. We use it from there and things like that. But that's probably the big specific thing about the nitrogen cycle that's important is that the need for nitrogen fixation. And then you've got phosphorus and sulfur. With phosphorus, a lot of times they make a point of the fact, I've seen it twice, where the fact that phosphorus does not have a gaseous form. I've also seen that they talk about the fact that phosphorus doesn't dissolve very well. So phosphorus is really kind of limited. It typically is almost always in the lithosphere. Things need it, but it is limited availability. That's what oftentimes makes it a limiting factor in food chains and stuff. And you need that. You can't have things just completely growing out of control. You need to be able to keep an ecosystem in check, so to speak, or you'll deplete permanently other things. Sulfur, I never really see anything about sulfur cycle. It is one of the major cycles. Just know that there's a lot of bacteria that metabolize sulfur. This is also why you have acid mine drainage when you dig sulfur up and the bacteria start to feast upon and produce sulfuric acid as a byproduct. All right, when it comes to biomes, I would try to visualize what that biome is like, and therefore maybe that can help you to remember what it's like precipitation-wise, temperature-wise, the different types of plants and animals that you find in those areas. This is a lot of different things to compare, so one of the best ways to do that is to look at a comparison table, which we have there. So you might want to go over that. Usually the part that people are not familiar with is the soil. So you might want to take a look at and remember a little bit about each one of the soil types in the different biomes. One of the most common things for them to ask about is rainforest soil, and the fact that rainforest soil is very low in nutrients. It's actually very weak soil. People tend to think, I think otherwise, that it would be, it's a rainforest, so it must be good soil, but it's actually not. Otherwise, your biomes they are the way they are primarily because of precipitation. So you can see these are arranged by precipitation, and second to that then is temperature, as far as what makes the biome what it is. All right, we also have the marine equivalent of biomes, which is your marine life zones, they oftentimes call it. You can call them aquatic biomes. These are some of the major ones here. I really have not seen a lot on the exams about these, more so about terrestrial biomes. So it wouldn't hurt that you kind of can, like I said, visualize and know a little bit about each one of these different types of biomes, where they occur, what kind of organisms are in there. But I wouldn't spend a lot of time memorizing specific characteristics of these different ones. One of the things that would be good to know, though, is what you can expect in the different areas of the ocean. And you saw a diagram similar to this on one of your questions. You don't need to remember these names here, but you would need to know that, for example, most of your productivity is close to shore. Then you have the open ocean. You have the zone at the top where you have sunlight penetration, so that's going to be, of course, be a big factor in the food chains and stuff that are there. And then, of course, you have the areas below the deep ocean where you don't have sunlight penetration, and these organisms have to depend upon the waste products that filter down from above, and they also, of course, have to be well adapted to high pressures. Okay, so just some of the basics about, the different areas of the ocean, what kind of productivity and stuff you might expect there would be good or sufficient. And then succession gets a good bit of attention on the exam. For whatever reason, it is an important concept. Perhaps because we tend to clear out land and therefore succession takes place afterward, whether it's through deforestation or agriculture, things like that. You do have a process of life begetting life, so to speak, in that you have pioneer organisms that can live off of rock as long as there's some water there. And they will then produce their own waste products, and there'll be things that come along, bugs and stuff, they'll come along and eat it and also leave their waste products or die there, and that's organic material. So once you get organic material and the rock starts to break up, oftentimes from these pioneer organisms, you now have bits of minerals and organic material, that's soil. Once you have a little bit of soil there, you can start getting shallow-rooted plants, and then they, once again, will attract things to eat them and to live there and stuff like that. More organic input from those organisms means deeper soil still. If you have the right temperature and weather and rain conditions, mainly rain conditions, then that area, that cleared area, will eventually become a forest after a certain period of time, a hardwood forest specifically, with these old growth, slow growing hardwood trees that take about 200 years or so to mature. Okay. But that does not always happen, of course. That's why we have grasslands, we have deserts, we have tundra and things like that, because the physical conditions can limit that as well. Another physical condition that often limits, particularly here in Florida and the grasslands, is fire. Fire can keep, for example, forests from becoming in hardwood type forests, and it can also keep grasslands as it burns down any trees that tend to grow up. But fire is actually a good thing. So this illustrates the concept of the fact that a fully matured climax community forest, what we call an old growth forest, looks nice. You think that's got to be the best thing. It's undisturbed. Nobody's done anything to it for hundreds of years. But it actually is not the most bioproductive or biodiverse and productive ecosystem habitat. The reason being, these trees are old, they're growing slowly, they're not doing that much photosynthesis anymore, they block out the sunlight on the bottom, their tree, the root structure and everything keeps things from sprouting underneath, even if it can handle the low sunlight conditions. And like I said, they really don't have that many organisms that they're supporting. So nature fixes that, either on a large scale with things like fires and natural disaster, or on a smaller scale and just simply the trees growing old and dying and falling over and rotting and stuff like that. Opening up the forest floor basically is what the goal is here. Once that happens, you can go through that whole succession process all over again with all your different species and things that you get along the way, and therefore the biodiversity increases by what seems to be a bad thing in the case of forest fires or storms, or termites and elephants, for example, is another way that these things can happen. Alright, so you get to see some pioneer species on lava rock. Lichens are also... Now, aquatic succession is very similar, except that the bodies of water are filling in with sediment as it goes along. You have oligotrophic. You want to know these terms. They have come up before. Oligotrophic, mesotrophic, and eutrophic. This is the natural eutrophication, not the bad cultural eutrophication. Notice you have a lot of plants and stuff growing in there, not just a bunch of algae. And so there's a lot of biodiversity in there and everything else. If that body of water does not have flow through it, like a river or a spring or something like that, that will flush out the sediments, eventually that constant input of natural input of sediments will fill it in, and you end up having what they call a bog or a wetland area after time, sometimes thousands of years before that it gets to that point. But that is the end state.
Can you name them one more time?
Pardon me?
Can you name them one more time?
Oligotrophic is your newest, youngest lake with the least amount of nutrients. Mesotrophic is just basically in the middle. A lot of times it's starting to develop, plants and stuff along the side and on the bottom. And then eutrophic is the final stage, and it is where you've got a very dense amount of nutrients and growth and things like that. I believe if you look back, right here.
Oh, okay.
Okay? Oops, I can't highlight that. Well, there you go. Oligotrophic, mesotropic's in the middle. Meso, middle. Okay? All right. Lo and behold, that's it for Unit 2, Ecosystems Ecology. Any questions about Unit 2? Okay? All right, Unit 3 is populations. We have our K and R strategists. They call them strategies because of the strategy or the goal of a population within an ecosystem is to produce another generation of offspring to continue to carry on the line, so to speak. So you have two ways of accomplishing that. K strategists do it by growing slowly, having maybe multiple matings, and when they have offspring, they take care of them and try to ensure that they grow to a ripe old age so they can have children of their own. Our strategists tend to produce as many offspring as possible, let them out in their environment. They're on their own. A lot of times they only live a short period of time. Sometimes only a lot of them, like insects, die right after they mate. And so their populations tend to jump up and down. They also tend to be limited by different things. So this is, I would look at, hopefully you still got this in your notes, the breakdown of the table on that. Okay, sure. Bye. Ms. Moore. Toodaloo.
Why are you not leaving early?
I would try staying in class.
Anyway, check the video, Ms. Moore. It'll be online. So anyway, both of those populations can be represented the way they grow into an ecosystem, so to speak, by growth curves. They're both on here. The K strategists have an S-shaped growth curve. They go along at the beginning what we call lag phase, just kind of getting comfortable with the ecosystem. And then once they're fed, they have shelter, etc., they will breed at their reproductive rate, which is what's known as their biotic potential, which, if unchecked, would continue to go this way up here. But what happens is that they start to get crowded, so they start running out of food and shelter, they start getting preyed upon by other animals and those kind of things. All these things decrease their birth rate, increase their death rate, so the population numbers will tend to settle out along what we call carrying capacity. It's basically the number of organisms that particular ecosystem can support of that particular species. Okay, so that's an S-shaped growth curve. These populations tend to work their way to a carrying capacity and stay steady at that level for a long period of time. Hence the old age and taking care of their young and that kind of thing. Now, our strategists think of small organisms, short lifespans, insects, etc. They will, when the conditions are right, like when it's hot and rainy, take mosquitoes for example, they will go out and get in the puddles and eat, and then breed and produce their offspring. And their offspring will hatch and come out, and their numbers will jump way up, and you'll see a lot of mosquitoes around. Then what they do, typically their larval stages when they do their eating, once they become adults and get out there, their main goal is to reproduce. And then actually, it's once they have reproduced, the females will look for blood, and then they'll feed their eggs, and then lay their eggs and die. And so their population's numbers will drop down, and it does tend to coincide with the seasonal changes. So by the time they're ready to lay their eggs and everything, the temperature will have started to go down again, and then those eggs are like cysts, they stay dormant for a while, and then the population numbers explode again later. So, limiting factors here, represented by arrows here, are the green ones and the black ones for the K strategist, is because the population is too dense. R strategist just tends to be things like weather changes, their life cycle is designed around it, those kind of things. And that's why you have that up and down, very abrupt changes in populations that you see with our strategists. This also means that when it comes to survivor curves, that since K strategists take care of their young, they tend to be up here with high survivorship when they're young. And of course they start dying off when they get older. Sorry, Grandma. And then your R strategist will produce a lot of offspring, like the oak tree produces thousands of acorns, but only a few of them are actually going to sprout and grow into trees. But once they do that, they're going to stick around for a while.
Why is that baby's head so big?
I don't know.
Got a big old brain.
Big old head on that baby. Big old bubble head. All right, human populations. This is actually more of a sociology thing than an ecology thing. It's not really an ecology thing at all. But we look at the demographic transition in this, where you start off with a pre-industrial, primarily agricultural society, high birth and death rates. Your birth rate minus your death rate is your overall population growth. So since those are close together, the population tends to stay relatively flat. And then they get introduced to things like better nutrition, antibiotics, better sanitation, etc. So the death rate drops down, but the birth rate tends to stay high for a while because it's still advantageous and it's a cultural thing. Eventually, the economy in these countries will change to the point where it becomes an advantage for both spouses to work, and therefore the role of women in those societies changes from just being a mother and having as many children as possible to somebody who goes to school and gets educated and may have children. And so consequently, of course, the fertility rate, the average number of children per woman drops in that society. And if you keep going and that fertility rate drops below 2.1, what we call replacement fertility, your deaths eventually, once these people that are born here become old, your deaths are going to outnumber your births, which means you're going to actually go into a negative or decreasing population at the end of the post-industrial. Okay. So you want to know those different phases and the different birth rates, etc., and the changes that cause those things. Histograms, you should be able to look at these real quickly and tell which one has the fastest growth rate and represents a transitional society versus which one has a moderate growth rate here where it's kind of even. You can expect zero to slow to zero growth. That would be an indicator of an industrial society. And then if you're top heavy, shaped like a coffin, and you've got a lot of older people and people that are going out of their reproductive years, that is going to be a society where the deaths are greater than the births, and therefore it'll have a negative growth, and that will be a post-industrial society. You go ahead and get one of those next. Questions? Anybody? Okay. All right, Unit 4 is our resources unit. Natural resources, those are the things we get directly from the environment. Water, of course, is the biggest one. We use it mainly for agriculture and industry and municipal uses in that order. The municipal being the flushing, drinking, and washing that we do at home. And so you'll want to just basically know that and what they're used for in each, kind of self-explanatory. And then how you can conserve water in each one of those. When it comes to agriculture, you want to reduce evaporation by using things like drip irrigation, and you also want to control runoff by creating terraces and flattened crops and fields and things like that, so the water soaks down the ground rather than running off. It also conserves soil. Industry, the main thing you use water for is for cooling and for water for steam engines, for generating electricity. Therefore, one of the big losses is through evaporation. So if you cool that water off before it's exposed, you can reduce the loss to evaporation in industry and also reduce thermal pollution. And then finally, municipal, just things, shorter showers, bigger wash loads, just basic water conservation things you probably should already know. And then also some of the things that happen when water is overused include saltwater intrusion, because the water pulls in salt water from the surrounding areas. You find this in coastal areas. Also, you can draw the water table down to the point where it creates a pocket and the sinkhole happens from that if you overuse your water supply. and soil salinization, which is not, I don't have a diagram for that, but that's when the minerals that are dissolved in the water build up over time and basically ruin your crops because you're using more more surface water and groundwater rather than precipitation. There's some terracing going on there. Then you got your soil resources. This is the second most important resource within an ecosystem is the soil after the water. It therefore is also the second most important thing in agriculture because agriculture, our crops are of course our own little ecosystems basically. So we need to conserve the things that deplete soil are erosion, both water and wind. So anything you can do to reduce that would include keeping the soil covered with plants and stuff as much as possible, leveling the ground out, using contour plowing and things like that to reduce runoff from washing it away, maintaining windbreaks in the form of trees and stuff to reduce the wind blowing the soil away. All those are soil conservation techniques. The other way in which soil is lost is it becomes demineralized, which means it loses its minerals. A lot of times that is from poor farming techniques, like always planting the same thing, never letting your crops rest, over harvesting. In other words, trying to get too much out of the soil, and the soil ends up getting depleted. And therefore, the opposite of all those things like crop rotation, using organic compost. And also, oh, by the way, acid deposition, of course, also depletes the soil because the acids wash the soil out more. We talk about that more in the pollution unit, so we'll save that for then. You should know the characteristics of soil as far as particle size goes. Very common for the ask about soil, sand, silt, and clay. Sand's got the biggest particles. It has the most air pockets, therefore has the least water retention. Water tends to go through a sample. Clay has the smallest particles, therefore it tends to hold water back the most to the point where it can actually form an impermeable barrier. And silt is in the middle. So if you remember those, if you don't know how to do the triangle, I wouldn't worry, lose too much sleep on it. This was on last year's exam, the 2016 exam, so that's the first time I've seen it. Not to jinx you or anything, but I'd be surprised if they put it on there again. But they might. It's not that hard concept. So you can look at the instructions there on the right-hand side. Layers of soil, topsoil, subsoil, and bedrock. So that would be horizon A, horizon B, and horizon C. Sometimes people refer to the O horizon. O is for overlay, and that is just basically the leaves and other kinds of stuff that are on the ground. Of course, you have a lot of that in a deciduous forest, for example, because they drop their leaves every year. There's some ways, some different soil conservation techniques, so familiarize yourself with those. Now, agriculture, of course, is the ones that depend a lot on the soil and water resources. And what we find is that traditional farming techniques that have been developed over thousands of years, planting a variety of crops, rotating your crops, using organic fertilizer, using a wide variety of pest control techniques, that actually is better overall for the soil, it's better for the environment. The only thing is it's not really high on the productivity level here as industrial farming. Now it's important to note that industrial farming was really born out of what we call the Green Revolution. And in the Green Revolution that's happened after World War II, genetically engineered crops were introduced all around the world, particularly in developing nations. And the output increased dramatically. Some people have claimed that up to 1 billion people have been saved from starving to death because of the Green Revolution. So certainly a very good thing in feeding people, which is always a good thing, of course. But we see a lot of environmental drawbacks because with this increased productivity, it requires increased amounts of water, increased amounts of fertilizer and pesticides. And so we deal with a lot of the environmental impacts of agriculture because of that. Also, it made the farming big business. It became more profitable to be big farms. But prior to that, the majority of your farms were family-owned operations and stuff. And part of the benefit of having that farm was, using its products to feed your family and stuff. Maybe do some trade and everything of the surplus. But with new mechanization and these new crops and new chemical fertilizer, that kind of thing, it became possible to increase the output so much that it became a profitable venture. And of course, as we know, once you get industry and profit involved, then the sky's the limit kind of. So a lot of times there you see problems associated with that. So just kind of picture what a traditional farm would be as opposed to an industrial type farm, and the pluses and minuses of both. Now, eating meat or raising livestock has its own unique problems. It is more environmental impact. The key reason for that is the fact that meat is, of course, higher on the food chain. And therefore, if you want, for example, 100 calories of chicken, how many calories of corn that you're going to feed it with do you have to raise to do that? 1,000 is correct. Very good. So it's a tenfold difference. So that means you basically got 10 times the agricultural impact by eating meat than you do by eating vegetables and things like that. There are also specific things that overgrazing and soil erosion and animal waste is a form of water pollution. We talked about that bit when we talk about water pollution. Those things also are big factors, environmental impacts of eating meat. So it is better to have a primarily vegetarian diet or grain diet for the environment. What we see is also the fact that developing nations, because it is expensive to raise the meat and everything, tend to have more of a grain-based diet. But as the world becomes more industrialized, the standard of living raises in many countries across the world, more people are eating meat, and therefore we're seeing more environmental impact from that. Any questions? I'm going to end it there. We will continue on with the rest of 4.